Okay, let's get started. Thank you everybody for coming today to the Integral webinar. I'm glad to be here, and we're going to talk today about passwords, web security. We're going to talk about password encryption and how to store passwords securely and safely. And then we're going to get into a bit about some mathematics. We're going to talk about hashing, salting, and we're going to talk about how to use tokens and how to use sessions in order to log a user in. It's really kind of an overview of web application authentication is what we're going to be talking about today. And I'm really excited to share all of this with you. So thank you for coming. If you have any questions during the webinar, you can put them in the chat, or you can put them in the Q&A. I'll be able to see them in either place. And periodically, I'll ask for any questions, or I'll look through the chat. So please don't be shy. If there's something that wasn't clear during the presentation, please go ahead and share it. And there's also going to be time after the webinar to go over any extra questions as well. So let's get into it. First, I want to tell you all about me. A little bit about like my background, where I've worked and what I do. I've been working on web applications ever since I graduated college. And at all of these three companies that you see on here, GuideCX, TaxBit, those are startups in the Salt Lake area. And both of those startups were for web applications, and they all required some form of user authentication. And now I work at Integral, helping great teams to build great products. And I love that job, and we continue to work on web applications here. And all of these web applications, they have one thing in common, which is that they require authentication and authorization. It's pretty hard, especially nowadays, unless you're making like a blog or something, to create a web app that doesn't need some kind of authentication and authorization. So before we get into how we authenticate and authorize people on the web, I wanted to spend a little bit of time to even talk about what those terms mean, because they're different. And I think this is an important distinction to draw between those two terms. Authentication, which is what we're mostly going to be talking about today, answers the question, is this person who they claim to be, right? Specifically, it's like a technological way to answer that question, is this person who they claim to be? The most common way to do that is by asking them for a password, which in theory only they should know, right? And authorization is saying, okay, now we know who you are, but what can you do and what can you not do? Today, we're mostly talking about, I went to the wrong slide here. Today, we're mostly going to talk about authentication. Sorry, I need to go forward here a bit. There we go. Now we're on the path again. We're going to mostly talk about authentication, which is that process of checking if this person is who they claim to be. And we're going to go over how that would work in your typical web application. But before we even do that, the question is probably going to come up, like if I'm let's suppose I'm a new product owner, we're about to create this new application. And the first thing you're going to need to do is find a way to authenticate users. The question is going to come up, should we create, or how much of the authentication system should we create ourselves? And the answer is that it depends. It depends on the needs of your application. If you have a very complicated app where maybe your users have, let's suppose your users can only do certain things. You need very fine-tuned access controls for certain users. You might not have the choice. You might need to create some kind of custom authentication system. If you have compliance requirements, you might not have the choice there. Either way, there could be a chance that you have to use a pre-built authentication system, and there's a chance that you would have to make a custom authentication system depending on what the compliance requirements are. And you'll always have to think about the time investment. It takes a lot of time to create an authentication system, and even more time to create custom authorization systems. And they're complex. And that's something to really keep in mind. Storing passwords, especially users' passwords, well, any kind of password, is inherently risky and complex. It takes a lot of, quite frankly, it takes a lot of mathematics. It takes a lot to do it properly. Most of these have been created in libraries that you'll be able to use already. But there's just a lot of edge cases. There's a lot of things, details that most developers are superficially aware of, but not in a really deep sense, right? So most developers are like aware of these things, but in order to create a really secure, robust authentication system, it takes some specialization, and so it's really significant I highly recommend thinking about using some other library or some framework that can do most of this work for you. And then today we're going to go over kind of how those things work. For instance, you could use a identity provider like AWS Cognito, or you could use Google Sign-In. You could use Google Firebase in order to sign in users, or if you're using a web framework like Django or Rails, a lot of those come with pre-built authentication libraries that you just have to integrate your application with. Or if you're doing Next.js or React, there's this library called Auth.js, which I've personally used and I really like. So before you start writing all of the code yourself, I highly recommend looking into these tools in order to do the authentication for your web application. These take a lot of the work out of it, but you still need to know how it works generally. And that's what we'll be going over today. When you use those tools, you might be presented with some options for different ways that you want users to be able to authenticate with your application. The most common way, and the way we're going to discuss today, is using emails or usernames and passwords. And a up and coming way of authenticating people is with email alone, or like a link alone. You click a link, sometimes they send you a code, you have to enter the code, and that's how you authenticate people. And another very common way is signing in through a third party like Google or Facebook, or if you're a developer, a lot of developers like to use GitHub. And if your application can support one of these authentication methods, especially the sign in through a third party, I highly recommend it. Those third parties, like Google, they are experts at this. They know how to build an authentication system. Their authentication system is used all over the world. It's very secure. And so if your application can support it, I highly recommend integrating with those. That takes less work than building your own. But you still should probably know how it's working, which again, that's why we're going to go over this today. And we're going to go over that in terms of using emails and passwords. Before I go on, let me just check for any questions here. If you have a question about anything I've said so far, please throw it in the chat. I'll give you a second. And otherwise, we will keep going. Okay, let's move on. There's one prerequisite, a piece of knowledge you need before we can talk about how to securely authenticate people. And this is kind of an essential, not kind of, it is an essential idea in web security. And it gets used all over the place, and these are called hashing algorithms. I love hashing algorithms, especially doing the research for this presentation. I just gained a newfound appreciation for them because they are used everywhere. They're very important, and they are absolutely essential to web application security. So we need to know what they are because we're going to have to use them in order to start authenticating people with usernames and passwords. So what is it? A hashing algorithm is a one-way cryptographic security method, or in English, it's a function that takes a string of data. In our case, we're going to talk about hashing text here, but you don't just have to hash text. It takes the string of data and it outputs something that looks unrelated to the original string that you sent in. And it's pretty easy to run it in that direction, right? It's relatively computationally easy to take a string of data, hash it, and get some output. But the thing about hashing algorithms, and this is a very important property, is that it's computationally infeasible to reverse the algorithm. So if you only had the hash, that's what we call the output of the function. If you only had the hash, the only way to solve for x in this second diagram here is to guess and check. So the only way to solve for x is to set x to something random that you hope was the original value, and then hash it and see if that is the hash that you want. And depending on the strength of the algorithm that you chose, this could be easier or harder, but it's that computational infeasibility. It's not impossible. It just takes a really long time. It's very difficult. That is what makes these secure in a way. They're not secure on their own. We're going to talk about what else you need in order to be able to securely keep track of passwords here. But this algorithm is very important, or that property is very important. That's what I meant to say. They're kind of old too. Hashing algorithms have been around at least since the 70s. That's what I could find in my research here. And they get used everywhere. I can almost guarantee that you've interacted unknowingly, probably, with a hash algorithm probably today. Seeing a question, can we have access to the slides? Yes, the slides will be posted and you will get a link in an email after the webinar today. So password or hashing algorithms, they get used in password verification. That's the use case we're going to talk about today. But they also get used in the blockchain, and they're actually central to the blockchain. If you've ever mined for Bitcoin, really what you're doing is running a hashing algorithm over and over and over again on different inputs until you get a certain output, is what you're mining for in the blockchain. They're kind of central to that. They get used in file compression algorithms, digital signatures, which we're going to discuss today as well, and then storage systems as well. They're everywhere. So you've probably used one today without even realizing it. In the umbrella of hashing algorithms, there are some well-known algorithms, and there are like, how would you say it? There are specific algorithms, right, within this umbrella. The one that is currently recommended from OWASP, a very well-known security organization, is called Argon 2 ID. And it's recommended because it has these knobs you can tweak to find a balance between performance and how much work it puts into the hashing. That's why it's currently recommended from them. And it won the 2015 password hashing competition. I don't know how frequently they do that competition. That sounds kind of old, but as of yesterday, it is still the recommended password hashing algorithm from OWASP. The more well-known algorithms that developers are generally more familiar with are like the SHA family of algorithms. That stands for Secure Hashing Algorithm. That's created by the NSA, who has a very valid stake in needing to know about hashing algorithms and needing to make a good one, which they certainly did, and the MD family of hashing algorithms. And one thing to note is that as time goes on, these algorithms become, and as computers become more and more capable, these algorithms need to be updated, and they need to output larger strings of text, larger hashes, in order to maintain that computational infeasibility, right? So like SHA-1, no longer recommended that you use that, or MD2, no longer recommended that you use that. We'll get into why that is in a second. There are a few important properties of hashing algorithms that we need to understand before we can understand how web security works. We talked about one already, which is that, let me go back there, which is that it's really easy to create the hash, but infeasible to figure out what the hash was created from, right? That's one very important property, but there are some others. First, hash functions are deterministic. So they always output the same thing. If you input a certain thing, they will always output the same hash. That's very important because we aren't going to be able to verify people's passwords if we don't have a deterministic function. There's no element of randomness in here. And they always output something of a certain size. So for instance, the SHA-256 algorithm always outputs something that is 256 bits long. That's why it's called secure hashing algorithm 256. It always outputs 256 bits. But importantly, hashing algorithms take something that is arbitrarily large. So you can put in a gazillion characters into a hashing algorithm and it will hash it. But it will still output something that's only 256 bits long. Now, there's an important problem here, which we're going to talk about. The fact that there are infinite inputs, but finite outputs means that there's some interesting ways that we can attack these hashing algorithms, which the developer of a web application should be aware of. Especially, let's consider this our database today. Let's think about whether or not this is secure. If this is what we're storing about our users, this table here, we've got an ID, it's just a numerical ID. We've got an email and a password, and the password is just hashed, right? When they gave us the password, we sent it through, maybe we sent it through Argon2 ID, and then this is what we stored in our database. What are the security flaws here? What are the security flaws with storing it like this? Let's go through it. First of all, there's an idea called hash collisions, and these exist because of that problem I stated earlier. There's a limited number of outputs in SHA-256, that's 2 to the 256 power. That's a lot of possible outputs, like an enormous amount of possible outputs, which is why that's a current standard. But there's infinite inputs, theoretically. And so that means that hash collisions exist. And a hash collision is where you take two different inputs and you get the same output on two different inputs, which shouldn't happen. So in this diagram, Fido54 and I Love Lucy, and this is made up. This isn't actually these aren't the real hashes of those things. Though in this example, they output the same hash. You can see here, these two things are the same. And the problem with that is that if an attacker has your database, suppose you had an injection attack, and all you're doing is hashing algorithms, or all you're doing is hashing passwords, excuse me, then that means that if you're using a weak hashing algorithm, so this is something to be aware of, like MD2, it could be feasible that that attacker can find collisions for people's passwords. And in that case, he actually doesn't even have to know somebody's password for sure. He just has to find a collision. And if you're using a weak hashing algorithm, that's a weakness in your application to be aware of. And then there's the problem with reused passwords. If the attacker is able to print out your user's database table, which is already a huge problem, in this theoretical scenario, we're supposing that he has some kind of injection attack that he's been able to perform on your website, or he's gotten access to the database in some other way. If he's able to find two hashes that are the same, because hash algorithms are deterministic, that means that either one of two things happened, one of them being much more likely. These two users used the same password, or they magically had a hash collision when they created their passwords, which is very unlikely. So they used the same password, and now he can crack two passwords at the same time. And if they use the same password, it's very likely that they used weak passwords. And it's very likely that they used passwords that have already been leaked in a previous security incident. And when that happens, attackers have these tables. We call them rainbow tables, or a hash table, of all the very, very common passwords, or all the passwords that were leaked in prior security incidents, and then posted online, and then their corresponding hash. And so the he can, all the attacker needs to do if he has access to your table is take this existing pre-computed table and check it against your user's table. And if he has any of the hashes that are the same, then he knows what that person's password was, and he can get into the application. Now, in that case, something like two-factor authentication would help. And that would be good to implement on your system. But there are, and we're going to get into this, there are ways to get around two-factor authentication. And these two problems, that's why we salt passwords. Salting passwords is extremely important. And what is it? Essentially, when a user gives your application their password, what we're going to do is add a string of random characters to the end of their password. And this string is going to be unique for each user. We don't want it to be the same for each user. And it should be much longer than what I'm showing here. And we call that string a salt. And if you're wondering, yes, there is also a pepper. That is also something that you can do. I believe a pepper for a password would be like an envelope encryption technique. But today we're just going to be talking about salts. And what you store in your database when you salt a password is the email, the password, and the password is now the salt plus the password, and you hash that whole thing. And then you also store the salt in plain text, by the way. It's okay to store the salt in plain text. And what this ends up doing to the attacker is that now when they get the database, they don't have the option of cracking a whole bunch of passwords at once. They have to actually check one row at a time and try to crack that one row at a time. And they don't have any guarantee that that user was using any common password like 123 or password. And so they start running into that computational infeasibility that we talked about earlier. They don't really know if they're going to crack it. It could take them days to compute, it could take them minutes, and they have to do it one at a time, which is a significant barrier if you're an attacker trying to crack passwords. A couple notes about salts. They need to be random. They need to be long, much longer than what I've been showing you here. We're talking 32 or 64 characters if you can store that. And you should use a library. If you're going to be generating salts on your own, you should use a library for the random generation. Because if you don't use a library, it's very likely that you will not create a sufficiently random cryptographic method. This is something that like mathematicians would be creating. Highly recommend using a library to do that instead of trying to create your own cryptographically strong random string generator. So let's go over how we authenticate a user. I've got here a sequence diagram, and I really like sequence diagrams. They're a very efficient way to show interaction between parts of a system. We've got a user, the browser, and the backend, and time in this diagram goes from top to bottom. So let's suppose that our user submits a sign-up form, right? And what's going to happen once they click enter is that browser is going to send a request to our backend, and it's going to send along with that request the email and the password that they put into the form, into the sign-up form. Now, the backend is going to add that salt that we talked about. It's going to take the password, append the salt to it. It's going to hash the whole thing and then store that in the database. And so what you end up getting in your database is roughly something that looks like this. You'll probably have a lot more columns for a user's table. This is a simplified version. And then if the user wants to sign in, they go submit the sign-in form. The browser sends along essentially the same thing, the email and the password, right? And the backend now looks up the salt for that user's email. It takes the password they sent and appends the salt to it and then hashes the whole thing and check if that matches what's in the database. And if it does, that's good. They logged in. And now the question is, well, what does the backend send back to the browser to tell the browser that they're logged in and it's going to send them like a page, probably to some kind of landing page, or maybe a dashboard page where they're authenticated. But then the browser is going to communicate more with the backend. And how do they communicate the fact that this user is authenticated? Well, that depends on a architectural decision that you can make. You need to decide if your application is going to use tokens or sessions. We're going to talk about how both of these work today. First, we're going to talk about sessions. So in session-based authentication, it's essentially the same. This is mostly the same diagram, but what I wanted to show is that now, once the user logs in, we're going to keep track of some state. We're going to keep track of state on the back end, and we're going to have that state be reflected in the browser. And so what happens is that the backend service, when the user logs in, generates a session ID. And I believe that usually this would have like an expiration, and then there's a sessions table, or however you want to store it, that has a session ID, and then it tells you whether or not that user is logged in, probably also a user ID or an email. And that way, and that session ID gets stored in the cookie on the browser. And so every time the browser makes another request to the backend, that cookie goes along for the ride. And so what this means is that, let's suppose that the user wants to change their password. Like, they go to the change password page and they fill out the form there, and you do it, and the browser is going to send a post request to update the password. The cookie is going to go along for the ride with the session ID. And now the backend can check if that session ID is currently active. And if it is, and it has to do that talking to the database, that's an important note. And if that session is currently active, it'll go ahead and update the password and tell the browser that that worked. Now, there's one problem here, which is why I believe session-based authentication is not as popular as it was. It's still totally valid, still works. But there is one problem with scaling a web application. If you're working on a web application that's going to be servicing, I don't know, hundreds of thousands or millions of users, generally we scale these applications horizontally. So instead of adding more compute to an existing server, like adding more CPU, adding more memory, we generally just add more servers. And then we spread the load of all of the requests across all of those servers evenly. But all of those servers, in order to tell if somebody is authenticated or if they're authorized to do a certain action, have to ask the database. And so this ends up causing a bottleneck between all of the application servers and the database. And if you're doing this in a microservices environment, this problem gets even worse, right? And that's why token-based authentication is arguably more popular today. And so let's go over how that works. First, when I say tokens, most developers are going to immediately think of JWTs. And I wanted to ask the question here because I haven't found an answer yet. How do you pronounce JWT? I have heard JWAT. That's my preferred pronunciation. I've also heard JWT, as I'm saying now. I've also heard JOT. If you could, please put in the chat how you prefer to pronounce JWT. If you've heard of these before, if you haven't heard of it before, this is your time to decide how you would like to pronounce it, I suppose. Because I would like to know, and I will try to pronounce it the correct way. Okay, we've got JWT. I'm seeing JWT a lot. JOT, I'm seeing JOT. Okay. We're going to go with JWT. When I was a student and I was working on a web application for my college, everybody there said JWAT, and I think that might be the only place where they say JWAT. So that's how I learned it, and I've had to retrain myself to JWT. So we're going to go with JWT. JWTs are very similar, or the way that the browser gets a hold of them is very similar to the way it would work with a session ID. The difference here is that there's no storing the JWT in the database. That's kind of the whole point of a JWT. Now, when the user signs in, the backend is going to generate a JWT, and it's doing this with a secret that the backend knows, right? That it has, and it needs, that secret needs to stay secret. So only the application server knows it. And once it generates that token, the JWT, it's going to send that back to the browser, and the browser will store that JWT in its cookies. And I bet that if you went and looked right now in your browser, in the DevTools, you can find a JWT for whatever website you're logged in your cookies, which is very fun. I was actually doing that this morning. And another fun thing to do is to go decode that JWT. If you just Google base64 decoder and then copy paste the JWT from your cookies and then put it into the decoder, you can find a JWT that, or you can see what it says, because JWTs are actually JSON, or most of them are JSON, not the whole thing, but a good chunk of it is JSON, and that's why they're called JSON web tokens. And it's a standard which you can read. There's an RFC where you can read the whole standard that can be implemented by a bunch of different libraries in the JavaScript ecosystem. And this is what they look like. If you were to go into your browser, like I said, this is what you would see. And I've split this into 3 lines because they're made in 3 parts, separated by dots. So there's a header, and then a dot, and then a payload, and then a dot, and then a signature. And the header and the payload are what's base64 encoded. Quick note about encoding. Encoding is just a way to take data from one, what would you say? From one, I can't think of any word other than encoding, format, from one format to another format. And so base64, you can go back and forth from base64 into like regular text really easily. It's not secure at all. It's just a way of compressing things, really. And when you decode this JWT, this is what you get out. Notice that the header and the payload are actually JSON, right? And the header says, here's the algorithm that we're using for this token, and this is a JWT. And the payload says this person's name is John Doe, and they are an admin, apparently, right? And the signature is not base64 encoded. And we're going to talk about what that signature is made of and why that is secure. This is a bit of an oversimplification. So if you want to know the nitty-gritty details of how JWTs generate these signatures, please go look up the RFC, which you can, I believe I've linked to in the slides here. And you can read all about how to generate these signatures. The idea, though, is that you take the secret, that secret that only the backend server knows, and then you take the header and the payload of the JWT and you hash the whole thing. You append all of that together and hash it, and that ends up being your secret, or that ends up being your signature. And this means that unless you had access to that secret, you'll have a really hard time spoofing the signature, because if you add the secret's kind of acting like a salt here, and if you add the secret, or if you add anything to a hashing algorithm, to the input of a hashing algorithm, the output changes drastically, seemingly randomly. And so it's very hard to spoof this signature. So when the browser now sends that token along with its requests to validate that the user is authenticated, all the backend has to do is take the secret that only it knows, and then take the header and the payload, hash it all, and check that that signature matches what was sent by the browser. And that's how these help a web application stay secure. And an important note here is that it fixes this architectural bottleneck that we discussed earlier, right? Where all of the application servers now have to talk to the database. They don't have to do that anymore to tell if somebody is logged in. They can actually just validate the tokens on their own because they know what the secret is. And so they can generate new tokens and they can validate existing tokens on their own, and they don't have to keep track of any state with the database, which is why these gained popularity, because it fixes that architectural bottleneck. So now let's suppose that the user wants to change their password. They would submit the form. The browser sends, along with the request after submitting the form, a authorization with the bearer and the token. That's usually in the header. And then the backend validates that by hashing what was sent along with its secret. If it's valid token, then it'll go ahead and update the password and say that, that worked, a 200. Do you have any questions? Is the recording available after the presentation? Yes, it will be. Okay. So let's talk about some weaknesses with what we've just discussed. I wanted to point out 2 attacks that can be executed against both sessions and tokens. The first one is cookie hijacking. There was a few months ago, I don't know if anybody here watches Linus Tech Tips. I like that YouTube channel. It's a fun YouTube channel. A few months ago, their YouTube account got hacked, and the attacker put up some like crypto scam instead of all the videos on their YouTube channel. And I felt really bad for Linus Sebastian. He nearly lost his entire life's work, right? And the reason that was able to happen, he had 2-factor authentication on his Google account, on his YouTube account. And this attacker was able to get through 2-factor authentication. And the way they were able to do it was by sending the LTT staff, one of his staffers, an email with an attachment. And when they downloaded the attachment from the email, it was actually a virus. And it cloned that worker's browser. And when it cloned the browser, what the attacker got was all the cookies and the session IDs from that user. And so they could pretend like by cloning the browser that they were logged in to their YouTube channel, which is how they were able to put up new videos. Okay. Yeah. And so that's one way that both of these authentication systems have a weakness here, which is that if you click a link that's going to clone that browser, we call it cookie hijacking, and that's not the only way to do this attack either. Then there's not really anything stopping that attacker from using those tokens. That's why typically tokens have a timeout, or they have an expiration, and you typically also have a refresh token that you have to use in order to get a new one. There's another attack called a cross-site request forgery, where if you're currently signed into an application and you click a link, an attacker can formulate that link. Let's suppose that you're signed into a banking application. An attacker can formulate the link for the banking application to actually hit the application's API endpoint. And let's say, this is a made-up example, let's say it can transfer $100,000 out of your account into the attacker's account. If you click that link in like an email, your browser is going to make the request to get whatever resource it was that you clicked. And along with that request is going to go your session cookie, whether it's your JWT or your session ID. And the backend, the server for that request, won't necessarily, there is a way to fix this, won't necessarily be the wiser whether or not that was a legitimate request or not. The way you typically get around these is something called a CSRF token that validates that this came from a legitimate source. But I just wanted to point out that there are attacks against these forms of authentication that programmers need to be aware of if you're creating your own authentication system. And there's more than what I've listed here, a lot more. Actually, web authentication is a huge topic. It's very complicated. And so once again, that's why I recommend integrating with a third party where possible, or using a library to do most of your authentication for you. That's all I had for today. So let's go through any questions that people have. Is there anything that anybody, because we have an extra few minutes, anything that anybody would like more explanation on? Please, I'm saying, please spell it in the chat. I'm not sure what it was that you wanted me to spell. So if you could tell me what that was, I'm happy to spell it for you. But we will be posting the slides, and we'll be posting the a video recording of this webinar afterwards, which you'll get a thank you email, thank you for coming, and the links will be in that email. Is how you'll get access to those things. Okay. Okay, well, everybody, thank you for coming. I hope you enjoyed it. I hope you learned something new, and please keep in touch.